Okay, so we're going to be studying Descartes' rule of signs, and this is where you can tell the number of possible positive real zeros and negative real zeros. First, you're going to check the sign change in the polynomial, okay? And that's going to be the max number of positive real zeros or less than that number by an even integer. So first I'm looking at this polynomial p of x, and it goes from the first term to the second term, it goes from a positive to a negative. So that counts as a sign change. When it goes here, it doesn't change. They're both negative. And then it changes here from negative to positive, and then from positive to negative there, and then it doesn't change again. So because there's three sign changes, what that means is the number of possible positive real roots or zeros is 3 or 1, because it could be the max of 3 or less than that by an even integer. So subtract 2 and I get 1. So then to find the negative real roots, the possible number of negative real roots, we're going to do the same thing but from p of negative x. And to do it from p of negative x, because when you plug negative x in for x here, if you plug it into one of the even exponent terms, it's still going to come out to positive, so the sign there is going to be the same. So that is still going to be 2x to the sixth. But when I plug it into an odd, and I raise a negative number to an odd degree, or an odd exponent, that's going to change that sign, which means this is going to become a plus 5x to the fifth. So all the even exponent terms stay the same, so this is still negative 3x to the fourth. All the odd exponent terms change signs, so that becomes negative 2x to the third. This stays negative x squared. This changes to positive x, and that stays a negative 1. So now I'm checking the same thing with my sign changes. It doesn't change here. I have my first change there from positive to negative. It doesn't change again until here, and then it changes again here. I wrote the wrong signs on this one, so that should have been from a negative to a positive. So that's 3 sign changes, which means for the negative real roots, there's either 3 or 1. Okay, so we're going to be doing the same thing for this one more. And I have one sign change here from positive to negative. You got to pay attention to that first term. A lot of people forget that because it a lot of times won't have the sign on it. And then it doesn't change again till here when it goes from a negative to a positive. So for that one, there's going to be 2 possible positive real roots or 0, because you got to reduce it by an even integer, which is 2. And then to get the negative, we're going to find p of negative x. So that's going to change this sign, negative x to the third. Remember, I'm only changing the signs that are the signs of the odd exponents. This one stays the same. This one changes to plus 5x and plus 6. So my sign changes here. I only have 1, and that's it. So that means there's 1 negative real root. And what that means is there has to be 1 negative real root. because there can't be more than that, but there also can't be any less than that because you can't subtract 2 from it. So on this one, we're going to, let me move it up a little bit. We're going to use Descartes' rule of signs and then list the possible rational zeros, the p over q's, and then factor the polynomial. Okay, so Descartes' rule of signs, I have listing the positive and the negative. And for the positive, I'm going from p of x. Doesn't change here. It does change there. So there's one positive. To find p of x, p of negative x, it's going to be negative x to the 5th plus 2x to the 4th plus x minus 2. Remember, I'm only changing the terms with the odd exponent. So that means I have one sign change here and another one here. So that's going to be 2 or 0 negative real roots. So I'm going to go ahead and check. First I have to find my p over q, my list of possible rational zeros, which is going to be my p is either 1 or 2, my q is just 1, so I have plus or minus 1, plus or minus 2. So I'm going to check each of those in synthetic division, and I have 1, 2, remember that I have 2 zeros missing, the cubic term and the quadratic term, then negative 1 and negative 2. Bring the 1 down, multiply, 3, 3, 3, 3. This adds up to positive 2, and 0. So that means that 1 is a 0, or 1 is a root. So now I'm going to go to negative 1. And I'm going to use these coefficients now. This is now my quartic. So I'm going to use those coefficients, 1, 3, 3, 3, 2. I bring the 1 down, multiply with negative 1, add, multiply, add, multiply, add, multiply, and that combines to be 0 again. So that means that negative 1 is a 0, or negative 1 is a root. So now I'm going to do it with my cubic terms, which is these here, 1, 2, 1, 2. But I don't need to check positive 2. The reason being, I only have one positive real root, and I've already found it in 1. Okay, so I can go straight to negative 2. Bring down the 1, negative 2, 0, 0, 1, negative 2, and 0. So that means that negative 2 is a root. So when I write it in factored form, I have x minus 1 from that one. I have x plus 1. I have x plus 2. And then what's left is x squared plus 1. That's my quadratic that was left. So that's where that comes from. And because I can't factor that any further, that's the factored form, and I'm finished. So you go ahead and try this one with the same directions as the last one. List Descartes' rule of signs with the positive and negative possibilities. List the possible rational roots, and then actually factor it.